Welcome to Study Loop.
This is the answer to Chapter 13, problem number 38 from the Smith Organic Chemistry textbook. And this problem is asking us, it's giving us three pairs of molecules and asking us which molecule of each pair is going to absorb at the higher. So pardon me. So within each pair, it's highlighting a bond in each of the molecules and asking us which bond is going to absorb at a higher wave number by IR. And so the thing to keep in mind when solving this problem is that stronger bonds are going to show at a higher wave number on IR. And so each of these pairs of molecules, A, B, and C, is actually comparing a CsP2 carbon bound to something versus a CsP3 carbon bound to the same thing. So in A, we have a carbon-oxygen double bond. That's a CsP2 carbon bound to an oxygen versus a CsP3 carbon bound to an oxygen. And so the CsP2 carbon bond to the oxygen is going to be stronger than just a CsP3 to an oxygen. And of course, a double bond is always stronger than a single bond. So A, the double bond, is the stronger one. For B, it's exactly the same logic. The double bond between the carbon and the nitrogen is stronger than the single bond between the carbon and the nitrogen. And as we said, the stronger the bond, the higher the wave number. And then for C, again, we're comparing a CsP2 carbon bound to a hydrogen versus a CsP3 carbon bound to a hydrogen. And so, like I said, the CsP2H bond is going to be stronger than the CsP3H bond. And since the bond is stronger, it will show at a higher wave number by IR. And I've indicated each of the stronger bonds by just putting a red arrow under the bond. And so that is the answer to Chapter 13, problem number 30.